Nomenclature and structure of carbonyl compounds. Now we'll be discussing about aldehydes and ketones. Aldehydes and ketones are the simplest and most important carbonyl compounds. There are two systems of nomenclature, aldehydes and ketones. This is a very interesting topic because aldehydes and ketones are one of the major parts of organic chemistry. Aldehydes and ketones are often called by the common names instead of their IUPAC names because it is much more simpler. These are the general structures of aldehydes and ketones. The common names of most aldehydes are derived from the common names of the corresponding carboxylic acids by replacing the ending IC of acid with aldehyde. For example, if we have acetic acid, it is replaced by the last two letters IC by aldehyde, that is, we will obtain acetaldehyde. Similarly, benzoic acid, the IC is replaced by aldehyde. Therefore, we will get benzaldehyde. At the same time, the names reflect the Latin or Greek term for the original source of the acid or aldehyde. The location of the substituent in the carbon chain is indicated by Greek letters, that is alpha, beta, gamma, delta, etc. The alpha carbon being the one directly linked to the aldehyde group, that is, this is the alpha carbon because it is directly linked to the aldehyde group. As we all know, the COH is the aldehyde group here. Beta carbon the next, and so on. So this is the gamma carbon, and if we have one more carbon here, that would be the delta carbon. The common names of ketone are derived by naming two alkyl or aryl groups bonded to the same carbonyl group. The locations of substituents are indicated by Greek letters alpha, alpha dash, beta, beta dash, and so on, beginning with the carbon atoms next to the carbonyl group, indicated as alpha, alpha dash. Some ketones have historical common names. The simplest dimethyl ketone is called acetone. This is the ketone group here. So the carbon directly linked to this ketone group is known as the alpha carbon, and this as beta carbon, and so on. Since the bromine is attached to the beta carbon, the name of this compound will be beta bromobutyrylhaldehyde. The common names of ketones are derived by naming two alkyl or aryl groups bonded to the same carbonyl group. The locations of substituents are indicated by Greek letters alpha, alpha dash, beta, beta dash, and so on, beginning with the carbon atoms next to the carbonyl group, indicated as alpha, alpha dash. For example, we know propanol. Its trivial name is propionyl aldehyde. Similarly, 2-methyl propanol is known as isobutyryl aldehyde. And similarly, this 3-methyl and 2-bromo-butanol is named as beta-bromo alpha-methyl butyraldehyde. The IC of the acid is removed and the word aldehyde is added. It is just as simple as that. Similarly, the big compound here is named as 3-chloro-2-ethyl pentanal, whose trivial name is beta-chloro alpha-ethyl valeraldehyde. Alkyl phenyl ketones are usually named by adding the acyl groups as prefix to the phenone. For example, we have acetone here. So when this acetone is added to this phenyl group, its name would become acetophenone. Just this Ne is removed and the word phenone is added. Similarly, for this, when propane is added here, the name would be propiophenone. Similarly, for benzoic acid, it would be benzophenone. The IUPAC names of open chain aliphatic aldehydes and ketones are derived from the names of the corresponding alkanes by replacing the ending E with al and one respectively. For example, acetone. When acetic acid IC is removed and the word ONE is added for a ketone. Similarly, for an aldehyde, IC is replaced by an aldehyde. Therefore, it would become acetaldehyde. In case of aldehydes, the longest carbon chain is numbered starting from the carbon of the aldehyde group, while in case of ketones, the numbering begins from the end nearer to the carbonyl group. For example, this is the first carbon. This is the carbonyl group. So the numbering goes on from here. Similarly, in this compound 3-methylcyclopentane, this is where the carbonyl group is present. Therefore, this would become the first carbon and the numbering goes in such a way. The substituents are prefixed in alphabetical order along with numerals, indicating their positions in the carbon chain. The same applies to cyclic ketones where the carbonyl group is numbered 1. So the name of this compound here would be 1-phenyl-propane 1-on. This is the carbonyl carbon and this is the carbonyl oxygen of the carbonyl group. So, when the aldehyde group is attached to a ring, the suffix carbaldehyde is added after the full name of cycloalkane. So, the name of this carbon atom here would be 4-nitrobenzene carbaldehyde, or it also can be named as 4-nitrobenzaldehyde. The numbering of ring carbon atoms start from the carbon atom attached to the aldehyde group. So we know that this is the aldehyde group present here. So the numbering would start from here 1, 2, 3 and 4. So the nitro group will be at the 4th position. So the name of this compound would be 4-nitro-benzene carbaldehyde. Similarly, the aldehyde group is present at this position. So this carbon would be the first carbon and the numbering would start like this. So its name would be propane 1, 2, 3 carbaldehyde. The name of the simplest aromatic aldehydes carrying the aldehyde group on a benzene ring is called as benzene carbaldehyde. Let us now discuss about the structures and functions of some aldehyde IUPAC names. Structure: HCHO is a general form and the most simplest form of an aldehyde. Its common name is formaldehyde and its IUPAC name is given as methanol. Similarly, CH3CHO has a common name acetaldehyde. The structure CH3CH-OCH3CHO has a common name alpha-methoxypropanoaldehyde and IUPAC name as 2-methoxypropanol. While talking about CH3CH2, CH2CH2CHO, its common name is valeraldehyde and its IUPAC name is pentanal. CH2 double bond CH-CHO has a common name acrolane and IUPAC name as propane-2-enol. Now let us study about the IUPAC names of certain aromatic compounds. This structure here has a common name thaldehyde and IUPAC name as benzene 1,2 dicarbaldehyde. Similarly, this structure where bromine is at the 3rd position of the benzene ring, its name would be metabromobenzaldehyde or 3-bromobenzcarbaldehyde, or it can be also termed as 3-bromobenzaldehyde. Now let us study about the structures of ketones. The structure CH3, COCH2CH2CH3 has a common name diisopropyl ketone and its IUPAC name as 2,4-dimethylpentane 3-on. This cyclic compound here has a common name alpha-methyl cyclohexane, whereas IUPAC name is 2-methyl-cohexanone. The compound CH3 twice CHCOCH3 has a common name, methyl oxide. Its IUPAC name would be 4-methyl-pent 3N2-one. Common names of aldehydes are derived from the common names of carboxylic acids, or by simply adding the suffix aldehyde to the prefix that indicates the chain length. As we can see here, this is the simplest form of an acetic acid. This here represents acetaldehyde, and this is the three-dimensional structure of pentanaldehyde. In the IUPAC system, the prefix indicating the length of the carbon chain is followed by the suffix al in the place of e. Since the aldehyde group is always present in the end, it is not shown by any number. Common name for ketones is arrived at by adding the suffix ketone to the name of the alkyl groups present. A ketone is named by adding the suffix -one in the place of e in the name of the parent hydrocarbon. The number of carbon forming the keto group should be mentioned. For example, ethyl methyl ketone is named as 2-butanone in the IUPAC name.